Alright, in this first example we're drawing a slope field at the provided points for the differential equation dy dx equals 2x minus y. If you remember how to do this, all we're doing is we're identifying the slope at all of these indicated points and plotting a little slope line on our field to generate the entire slope field for this differential equation. So I'm just going to go through and find the values at a bunch of points. When x is 0 and y is 0, dy dx is 0, so I'll put a slope line with 0 there. When x is 1 and y is 0, the slope is 2. Oh, there we go. When x is 2 and y is 0, the slope is 4. When x is 3 and y is 0, the slope is 6. When x is negative 1 and y is 0, slope is negative 2, that's negative 4, and negative 6. And I'm just going to continue to generate slope lines in this fashion. When x is 0 and y is 1, that's going to be negative 1 as the slope. When x is 1 and y is 1, that's going to be positive 1, positive 3, positive 5. Okay, when x is 0 and y is 2, it's going to be negative 2. And it's going to be 0. And there's the first pattern that we see. We see that when we go up 2 and over 1, we can repeat a slope line here, since these are both linear factors. The slope here is going to be 2. The slope here is going to be 4. And let's fill in some more in. Where do I want to go next? When x is negative 1 and y is 1, that's negative 3. Negative 5 here, negative 7. When x is negative 1 and y is 2, the slope is negative 4. Negative 6. And negative 8. Notice as we get into these steeper slopes that it's hard to differentiate between a negative 6 and a negative 8. As long as it's a steep negative slope, you want to try and show differences as we move around the slope field, but it gets kind of difficult to tell the difference between the slope of negative 6 and negative 8. As long as it has the right sign and close to the right steepness, that hash mark should work for you. Alright, let's see what else we got down here. Now I should be able to generate most of the rest of these by pattern recognition. If I go down 2 and to the left 1, it has the same slope. And so I'm just copying slopes over from the second line of slopes above. Filling these slopes. Slope here is negative 5, negative 3, negative 1, positive 1, positive 3, positive 5, positive 7. And let's see, when x is 0 and y is negative 2, that's going to be slope of 2, matches up with that one. Slope of 4, 6, 8, and negative 2 over here, and negative 4. And we've generated a slope field for the differential equation dy dx equals 2x minus y. Let's do one more example in this video to see how far we can get. Example 2. Sketch the solution curve to the differential equation graph below that has the initial value f of 0 equals 1. And sketch the solution curve to the differential equation graph below that has the initial value f of 0 equals negative 3. So for part A, I'm going to do part A in blue here. I go to the point 0, 1 on the slope field, and that's right here. And then I want to use the contours of the slope lines. Now that slope is positive, and these grow positive very quickly here. And so my solution curve is going to grow positive very quickly. And as I move from the left of that point, still positive. It flattens out on this line. It looks like the line y equals negative x. And then the slopes start to go negative. And notice the little, what looks like almost a diagonal line that goes through. It looks like it's at about y equals negative x minus 1. That implies that this curve is going to get closer and closer, that there's almost an asymptotic behavior there. And there's a rough sketch of our solution curve for part A. Part B, I'm going to do it in pinkish purple here. And we want the solution curve for 0, -3. So I'm going to put a point down here at 0, -3. And if you look to the right of that, the slope lines go down very steeply in the negative direction. And come up, and the slope lines start to flatten out a little bit. Again, approaching that line where we've got an asymptotic kind of behavior. And there's how we sketch the solution curves. Okay, we'll end this video here and come back for more examples in the next one.